everybody again. So today we're starting chapter 11, Pythagoras' Theorem and similar shapes. Key words: right angle, hypotenuse, similar, corresponding sides, corresponding angles, scale factor of lengths, scale factors of volumes, scale factors of areas, congruent, included side, included angle. In this chapter, you will learn how to use Pythagoras' theorem to find unknown sides of a right-angled triangle. Learn how to use Pythagoras' theorem to solve problems. Decide whether or not triangles are mathematically similar. Use the properties of similar triangles to solve problems. Find unknown lengths in similar figures. Use the relationship between sides and areas of similar figures to find missing values. Recognize similar solids. Calculate the volume and surface area of similar solids. Decide whether or not shapes are congruent. Use the basic conditions for congruency in triangles. One man, Pythagoras of Samos, is usually credited with the discovery of the Pythagorean theorem, but there is evidence to suggest that an entire group of religious mathematicians would have been involved. Right-angled triangles appear in many real-life situations, including architecture, engineering, and nature. Many modern buildings have their sections manufactured off-site, and so it is important that builders are able to accurately position the foundations onto which the parts will sit so that all pieces will fit smoothly together. Many properties of right-angled triangles were first used in ancient times, and the study of these properties remains one of the most significant and important areas of mathematics. Recap. You should already be familiar with the following number and shape work. Squares and square roots. Chapter 1. To square a number, you multiply it by itself. You can also use a square function on your calculator. To find the square root of a number, use the square root function on your calculator. Pythagoras' theorem. Page 9 Mathematics. Pythagoras' theorem states that in a right-angled triangle, the square of the hypotenuse is equal to the sum of the two shorter sides. For this triangle, the hypotenuse is the longest side, and it is always the opposite the right angle. So a squared plus b squared is c squared. 11.1 Pythagoras' theorem. Centuries before the theorem of right-angled triangles was presented to Pythagoras, the Egyptians knew that if they tied knots in a rope at regular intervals, as in the diagram on the left, then they would produce a perfect right triangle. In some situations, you may be given a right-angled triangle and then asked to calculate the length of an unknown side. You can do this by using Pythagoras' theorem if you know the length of the other two sides. Learning the rules. Pythagoras' theorem describes the relationship between the sides of a right-angled triangle. The longest side, the side that does not touch the right angle, is known as the hypotenuse. For this triangle, Pythagoras' theorem states that a squared plus b squared is c squared. In words, this means that the square on the hypotenuse is equal to the sum of the squares on the other two sides. Notice that the square of the hypotenuse is the subject of the equation. This should help you to remember where to place each number. Where's example 1? Find the value of x in each of the following triangles, giving your answer to one decimal place. So, the value of x is the square root of 34 and the square root of 225, which are 5.8 and 50 centimeters when rounding. So, this is the end of the video. Thank you and goodbye.